Hamilstone.
Hi, this is Emmanuel Kadri and you are welcome to Hamilstone Academy. In this video, we shall continue from where we stopped in this topic called function. All right, so we've not really studied the function as a topic on its own. We are still just doing some kind of, introduction to just some very important concepts in that topic called function. All right, so the idea of this introduction is just to introduce you to a few things, just to discuss some basic things which you need to understand first before going into the main topic. So when we just start making mention of all these things, you're already familiarized with all those things and all that, okay? So that's just the whole thing behind it. So today in this video, we are going to be discussing direct and inverse variation. All right. Okay, when you say something is directly variable to something, it means that the other something, sorry for using something, when you say one term is directly proportional, okay, to the other, it means that this depends on this. As a matter of fact, this one is direct proportion or variation. Okay, while this one is indirect. Proportion. Okay, now the difference between the direct and indirect is that here A is directly proportional to B, which simply means that A depends on B. Okay, and then A depends on B directly. The word direct comes from the fact that if A increases, if B increases, A will also increase. If B decreases, A will also decrease, which simply means that anything that affects B affects A in that same proportion. That is the reason why we call it the direct proportion, okay? It means that whatever affects B will affect A in that same proportion. If B increases, A will also increase. If B decreases, A will also decrease. Okay? But on the other side, we have this indirect proportion. Just trying to make us to understand that if B decreases, A will increase. Okay? If B decreases, A will increase. But if B increases, all right, the opposite will happen to A, which means it will decrease. So for indirect proportion, although A depends on B, okay, although A depends on B, is proportional to B, all right, but whatever happens to B, it is in the opposite direction that it affects A. So that is why it is called the indirect proportion, or you can call it inverse. Better called inverse, inverse. That's actually the mathematics name, no. It's inverse proportion, okay? All right, but it's not as if the indirect is wrong, because you say something is indirectly proportional or inversely proportional to A. It's also, but this is just the standard term used for it, okay? So now, if you come back to this direct proportion, okay, let me just give you a real life example. The size of my stomach after meal depends or is directly proportional to the amount of food I eat during meal. It means that if I take 10 wraps of fufu, okay, my stomach will be big, all right? And if I manage to take 20 wraps of fufu, my stomach will be double the size it was initially for the 10 wraps of fufu. So the more the fufu I take, the bigger my stomach, which means that as the number of fufu increases, the size of my stomach as well increase. So that one is direct proportion, which shows that whatever is it that, which shows that the size of my stomach is directly proportional to the amount of wraps of fufu that I take. So that is direct proportion, because the more the number of fufu, the bigger my stomach. And the lesser the number of fufu, the lesser the size of my stomach. You get that? All right, so, but for indirect proportion or the inverse proportion, I'm just so used to calling it the indirect, the inverse proportion. For the inverse proportion, all right, the size of my body is indirectly proportional to the amount of work that I do. So which means if I do a lot of work, I have the tendency of dropping lean. All right, but if I relax a lot, which means I don't do much work, then I can get bigger. All right, so which means that, all right, the size of my body is dependent on the amount of work I do, but it is inversely dependent in the sense that the more the work I do, then the less the size of my body. And the less the work I do, the more the size of my body. So whatever is it that happens to one, the opposite of it is what happens to the other in that proportion. Do you get what I'm trying to explain? So that is the difference between the two of them. All right, back to mathematics. So this is a sign in mathematics which we use to represent the variability or the variation or the proportion, all right? But we cannot do anything with this sign mathematically. That is, we cannot do some kind of algebra. We cannot do calculations with this sign. We have to find a way of changing it from this proportion sign to something that can be useful, something that we can do some mathematical calculations around. All right. So, and that is where we introduce constants. Okay. So that's where introduction of constants comes in. Okay. So when we introduce a constant, then it will change this sign to an equality, but this constant will multiply the variable on the other side. So let me just show you how it is. So if A is proportional to B, then it means A is equal to KB. This constant, this K here is a constant term, okay? So now, this is a variable, okay? Are you getting me? This is variation, and then for variation to change to equality, we must introduce a constant. The same thing on the other side too. So if A is inversely proportional to B, and then we will say A is equal to K multiplied by 1 over B, okay? Or simply say A is equal to K times 1 is K. So you just say A is equal to what? K over B. All right? So for us to find the constant of proportionality, we can make it the subject of the formula, provided that we know the value of A and the value of B. All right? So let me just, let's just have one example or a couple of examples to explain the numeric part of this. Okay, so if, let's say example 1, the size of a ball, is directly proportional to the amount of air, or let me say to the volume of air pumped into it. Okay? All right. So if 20 cm cubed of air is pumped into the ball, all right, it increases to okay, let me just say the weight. Let me use weight, sorry. The weight, okay, it increases it has a weight of what? Of 20 newtons. Okay? The weight of a ball is directly proportional to the volume of air pumped into it. If 20 cm cube of air is pumped into the ball, it has a weight of 20 Newton. All right? What will the weight be if 45 cm cube of air is blown into the ball? Okay, so this is just like an example, all right? Okay, so to solve this question, we say, let the weight of the ball be W, and then let the volume of air pumped into the ball be V, okay? From what we have here, it said the weight of a ball is directly proportional to the volume of air pumped in. So if we interpret this thing, it means that the weight of a ball is directly proportional to the volume of air pumped into it, okay? In that case, if weight is directly proportional to the volume, then it means that the weight will be equal to kV. That is, we introduce the constant of proportionality into the system. Just to remove this sign, to change this sign to equality, we introduce the constant. All right? So if we do that, it means K is equal to W over V, if you agree with me. So this V, as it goes to the other side, it was multiplying K before, but it goes to the other side to divide. All right? Remember that whatever is it that is a sign or any operation on a term, okay, before it crosses the equality, it goes to the other side to serve the opposite of that sign or of that operation. All right? So as we have it this way, this is K is equal to W over V. So it means that the ratio of the weight to the volume is constant. That is the meaning of that expression. It means that the ratio of the weight to the volume is constant. In that case, we can say weight 1 over volume 1 will be equal to weight 2 over volume 2, and so on and so forth. Okay? It's just trying to tell us that the weight, the ratio of the weight and the volume is constant. That is the meaning of this mathematical expression. So in that case, we could just put it there. So if, in that case, you know, the first W, the first weight, that is the weight in the first instance, okay, the weight of the ball, blah, 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 the weight is 20 Newton, okay? The second weight is what the question is asking us to find. It says, what will the weight be? We don't know the weight, okay? But we understand that the first volume, which is V1, was 20 centimeter cube, and then the second volume, that is V2, is 45 centimeter cube. All right? So as you see it this way, as you have it this way, all you just need to do is to slot it into this equation, which is just trying to tell us that the ratio of the weight to the volume is constant. It means so weight 1 over volume 1 is equal to weight 2 over volume 2. That is when the two of them divide, it will keep giving you the same answer, the same constant result. That's what it means. And we are going to experiment it anyway. So let's have it this way. So weight 1 is 20 over volume 1, which is 20, is it 20 cm cube? Yeah, 20. Okay, good. 20. All right. Then that is equal to weight 2, which we don't know. All right. Divided by volume 2, which is 45. All right. Mathematics allows us to cross multiply when we have this kind of situation. So when you cross multiply, W2 times 20 becomes 20 W2, then 20 times 45, 20 times 45. So you can say 450 times 2, and that will be 900. So you have 900, okay? So at the end of it all, okay, W2 will be equal to 900 divided by 20. So 0 here, 0, and then this one will be 45. So W2 will be equal to 45, okay, 45 Newton. That's how it goes. So which means that, and if you want to try it, okay, from the old thing that we have here, if you just want to check it out to see whether the ratio is truly constant. Okay, this example seems to be too direct because coincidentally I used the same value. I wasn't even thinking about it, but yet at least it passes the message. Okay, if you check it out, you will see that 20. If you will see that now that we know that W2 is 45, you see 20 divided by 20 gave us 1. 45 divided by 45 also gave us 1. Even though we have other values too, we'll keep having 1 as the result. That is the constant number. You understand it now? It just tells us that the ratio of the weight to the volume is constant. If you can experiment with other values, just put other numbers there. You will see that the ratio of the two numbers will keep being the same as that number you got for k in the first instance. So it's just that way, okay? All right, so that is that as per that. This example or this question is an example of a case of inverse variation or inverse proportion, okay? Now, this question says the height of a boy, the height a boy can jump is inversely proportional to his weight, okay? So which means the boy's height is inversely proportional to his weight. That is what the question implies. Because of this inverse proportion, it simply tells us that when the weight increases, the height he can jump will decrease. And when the weight decreases, the height the boy can jump will increase. So when there is an inverse proportion, the opposite of what happens to one variable is what happens to the other variable, okay? But in a constant proportion, okay? Now, if this happens to be so, then we can change this thing to equality by indicating h is equal to k over w, introducing a constant, all right? If we introduce this constant now and we cross multiply, so we just assume that this h is like divided by an invisible one. Okay, so k times 1 is k, h times w is what? wh. So what this thing is just trying to tell us is that the product of the weight and height is constant. That is to say, the moment you multiply the boy's weight and the height, you keep getting the same answer, regardless of what the weight and the height is at the particular instance. It means you will keep getting the same answer, a constant result, whenever you multiply the weight of the boy by his height. So that is what this relationship is explaining to us. Okay, now, let me just quickly put all the figures in. All right, when he weighed 25 Newton, okay, or you can say for 25 kg, or let's just make it kg for general understanding, in case of those who don't know about Newton. So when he weighed 25 kg, he could jump a height of 50 meters. So which means that when W1 is 25, okay, H1 is 50, all right? So when we say K is equal to this, what this guy is just trying to tell us is that the product of W and H remains constant. So W1, H1 will be W2 times H2, and so on and so forth, W3 times H3. Any value of W we have, okay, if we multiply it with any value of H that we have in a particular instance, we'll keep getting the same results. That is the reason, that is the meaning of this, and you can test it on your own, okay, because I just don't want this video to be so long. Okay, so let's just do it. So we have W1 on these. If you multiply it now, okay, and in this question, it said, how high can he jump? So we are looking for H2. We don't know H2, but we know that W2 is 100 kg. So we know that W2 is 100 kg, okay, but we don't know the value of H2. So using this relationship, we can just say, okay, W1 H1, which is 25 times 50, is equal to W2, which is 100, times H2. All right, which H2, which we don't know. So you can just go ahead and say that H2 is equal to 25 times 50, all divided by 100. All right? So if you have it this way, you can just, let's just do cut. So this, we cancel this. All right? So 5 here, 1, and then 5 in 100, 5 in 10, sorry, is 2. Okay? Now, 25 divided by 2, that will give you 12.5. So, which means H2 is equal to 12.5. All right? Meters. That is the answer. Now, if you want to test whether we are correct, multiply 25 by 50. Just get the value. 25 multiplied by 50 will give us, it's just like saying 250 in 5 places. All right? So 250 in 5 places, 250 in 4 places, that's 1,000. In 5 places, it will be 1,250. Okay, so which means that the constant value is equal to 1,250. So let's see whether we are going to get the same thing with this second situation. In this second case, we have W2 as 100, okay, and H2 as 12.5. So if you do 100 times 12.5, you see that the 2 zeros, we shift the decimal point forward 2 times, 1, 2. At the end of the day, you fill the empty space with a 0, so you have 1,250 at the end of the day, which is still the same thing. So it shows that the product of the weight and the height will keep giving you the same results, no matter what the weight is or the height is at a particular instance. That is the meaning of this. This product of W and H is constant. It's keep giving you a constant value. So that's just that as per that. All right. So this stuff will be useful for you in your scientific calculations, especially in chemistry and in physics as well. So it's just good to understand this. And then that is the end of this topic. See you in the next video. Bye.